Assalamu alaikum friends. Welcome to my YouTube channel. Today I am going to discuss how to implement genetic algorithm for automatic generation control of two-area power system in MATLAB Simulink software. Friends, to implement the genetic algorithms, first we need the conventional model of automatic generation control of two-area power system in Simulink. For your convenience, I am considering this simple automatic generation control model of two-area power system as shown here. On this topic, I have already made the video tutorial, namely how to design automatic generation control of two-area power system in MATLAB Simulink in two parts. Therefore, if you can watch this video and apply the genetic algorithms in this model to optimize the parameters of PID controller, then this model can be used for your master degree research or one of the PhD research objectives. Now let's check the frequency response of this model. Run the simulation by clicking on this play button. Double click on this scope to see the frequency response of area 1 and area 2 respectively. You can see its response is satisfactory, which is obtained after several attempts. However, if you notice the response, it still contains large undershoot, overshoot and very long settling time. Therefore, its response can be further improved by applying the genetic algorithm on this model. Friends, in order to compare the response of this model with and without genetic algorithm, first copy the whole model and paste it here. Now look at the model. It may be observed that in this model we are using three integrator blocks with gain block as shown here. It means that we can use three PID controllers in these places. Therefore, first replace all these three integrator blocks with three PID controllers. For this purpose, bring the PID controller block from here. Remove this integrator and gain block from here and connect the PID controller block at this position. Repeat the same procedure to remove these integrators and gain blocks from here and connect the PID controller blocks at these positions. Friends, in order to compare the response of this model with and without genetic algorithm, we need multiplexer block. Therefore, go to Simulink library, take the multiplexer block from here and bring it in the model. Connect the first port of the block with the output of this scope. Similarly, connect the second port of the block with the output of this scope. Now copy this scope and paste it here. Connect this scope with the output of the multiplexer block to get the combined response of both systems. Repeat the same procedure to combine and compare the response of area 2 with and without genetic algorithm as shown here. Friends, we know that every optimization technique needs a fitness function to optimize the parameters of PID controller. The fitness function in this model is considered as the error of the system as shown here. Most commonly, integral time multiplied absolute error is considered as the fitness function for the best results. Mathematically, this error is given as below. It may be noticed that for two-area power system, this objective function uses the change in frequency of each area as well as change in tie line power. Friends, this objective function is taken from the research paper as shown on the screen. I will attach this paper in the download link for your reference. You may download it from there. It may be further noticed from this equation that this error consists of integral of the error of change in frequency of area 1 and area 2 as well as change in tie line power multiply with time. Furthermore, the integral of time is taken from 0 to the final value of the time. Now suppose if we run the simulation for 50 seconds, then it means that time will be from 0 to 50 seconds. Let's design this integral time multiplied absolute error in the Simulink model. To get the absolute error for change in frequency of area 1, take this absolute block from here and bring it in the model. Connect this absolute block with this change in frequency of area 1 error signal to make it absolute error. Similarly, repeat the same procedure to get the absolute error for change in frequency of area 2 as well as absolute change in tie line power as shown here. To add all these absolute errors, we need sum block. Therefore, bring the sum block from here and bring it in the model. Connect all three absolute errors with the sum block as shown here. Look at the equation again. Now we have to multiply it with the time. Therefore, take this clock block from here and bring it in the model. Similarly, take this product block and bring it in the model. Now connect both clock block and output of the sum block with this product block in order to get their product. Look at the equation again. Now we need to integrate this error. For this purpose, take this integrator block from here and bring it in the model. Connect this block here. It may be noted that this integrator block will integrate the absolute error from time equal to 0 up to the total simulation time. In our case, the simulation time is set to 50 seconds. Therefore, it will integrate from 0 to 50. To see this error, take this display from here and bring it in the model. Connect this display here to see the error. Friends, we will shift this error to the workspace in order to use it for genetic algorithm. Therefore, take this to workspace block from here and bring it in the model. Connect it here. Double click on it and write its name as ITAE, which stands for Integral Time Multiplied Absolute Error. Friends, as we want to optimize the parameters of PID controller, therefore we have to change the fixed values into variables. For this purpose, double click on this PID controller block. Suppose we want to give variable name as KK. As there are three parameters of PID controller, therefore write here KK1, KK2 and KK3 as shown here in order to make them variable. Similarly, double click on this second PID controller block. Write here KK4, KK5, KK6 respectively. Similarly, double click on this third PID controller block. Write here KK7, KK8 and KK9 respectively. Friends, at this stage we have done necessary changes in the model. Now let's start to discuss the basic program for fitness function in order to use it for optimization. For this purpose, see the MATLAB screen. It shows the basic fitness function program to run. Friends, this MATLAB fitness function program is very basic and will remain same for all types of power system models. Therefore, you can use this fitness function program as it is for your model too. I will share this model and MATLAB function program in the form of link in the description section of this video. You may download it from there. Now let's understand this MATLAB fitness function program. The first line consists of initialization of MATLAB function having the name cost. It may be noted that the name of this function and the name of the MATLAB program must be same, otherwise it will give error. You can see both these MATLAB function as well as program has the same name as tuning. In the MATLAB program, tuning is written with kk in the parenthesis. This kk is similar to the kk variable which we have already defined in the model. It is because we are optimizing the value of kk. The second line consists of another built-in function, namely assign_in, which is used to assign any value from the model or workspace to the program. Therefore, this line shows that this function takes the value of kk from the model or from the workspace and assign it to the variable kk as shown here. Third line again shows another built-in function which is used to simulate the model in order to get the values of kk, which are basically the parameters of PID controllers. Friends, it may be noted that correct name of the model must be written here, otherwise it may give error. The last line shows the output, which is integral time multiplied absolute error. It may be noted that here length is written, as we know that the simulation time consists of 50 seconds. Now up to these 50 seconds there will be many values of error, but we want the last value at which time the simulation is completed. Therefore, this length is written to obtain the last value at the end of the simulation. Friends, at this stage we have done all the necessary changes in the model as well as in the program. Now we need to perform the optimization of PID controller parameter using the genetic algorithm. For your convenience, MATLAB has the optimization toolbox, in which various optimization tools are available, including the genetic algorithm. The command to open the optimization toolbox is optimtool as shown here. Therefore, write this code optimtool in the command window and press enter. You can see optimization toolbox window is opened. The first parameter consists of solver option. Click on this solver option. It will show many options to solve the problem. As we want the genetic algorithms, therefore click on this genetic algorithm option. Now it asks for fitness function. As we have already written the fitness function MATLAB program having the name tuning, therefore here we just need to call that function. This can be called by writing at the rate and its name tuning as shown here. Now it asks for number of variables. As we know that in our model 3 PID controllers are used. Each PID controller consists of 3 parameters known as P, I and D. Due to these 3 PID controllers, we will have in total 9 variables. Therefore, write here 9. Now it asks to define the constraints. Friends, in this section only bounds are important. It asks for lower and upper values of variables. In other words, it basically asks the minimum and maximum values of the parameters of PID controller. You may choose any values of your choice. However, some research papers have suggested to use the ranges from 3 to -3 or 1 to -1. Therefore, I am giving the lower bound to -1 and upper bound to 1. It means that the genetic algorithm will search for the best results by changing the parameters of PID controller from -1 to 1. Therefore, write here 1 9 times in the square brackets in order to define the lower bounds for all 9 parameters. Similarly, write here -1 9 times in the square brackets to define upper bounds for the 9 parameters. Friends, as we know that genetic algorithm consists of 5 main steps. Among them, the first step is initial population. Therefore, look at this section. You can see it asks for the population to define. In the population type, it gives various options. Choose any option of your choice. For better results, keep the population type as double vector. Now it asks for population size. You may put any value of your choice. However, I am choosing the default number of population size, which is 50. Now it asks for creation function. Again, here it gives various options. You may choose any option of your choice. For this model, I choose uniform option. Keep the setting of initial population, initial score and initial range as it is. The second step of the genetic algorithm is fitness function. Therefore, it asks here about fitness function evaluation. In the scaling function, it gives again various options. Choose any option of your choice. For this model, I have chosen the scaling function as rank. The third step in the genetic algorithm is selection process. In the selection process, it again gives various options. Among these options, all are good. However, tournament selection always has the best results. Therefore, I am going to choose the tournament option here. Keep the tournament size and reproduction option as it is, or you may change it if you want. Another step of genetic algorithm is the mutation. In this option, it again gives various options. You may choose any option. I am choosing the adaptive feasible option for this model. The last step of genetic algorithm is the crossover. In the crossover section, again it gives many options. I choose arithmetic option for this model in order to get the better results. Keep the settings of other remaining sections as it is for best results, or you may change it if you want. Friends, as already discussed, genetic algorithm needs stopping criterions to end the program. Here 100 multiply with the number of variables generations are set as default stopping criteria. In my opinion, it is sufficient. However, you may increase or decrease it depending upon your choice. I choose here default values. In the plot function section, select the best fitness option to see its graph. In the display to command window, select the iterative option in order to see the error at every iteration. Friends, at this stage we have successfully performed the settings of genetic algorithm to optimize the parameters of PID controller for this model. To start the optimization process using genetic algorithm, click on this start button. Wait for a few seconds. Come to the model. You can see it has started the optimization of PID controller parameters. Furthermore, it may be noted that this model screen is continuously blinking, which means that genetic algorithm is continuously running the simulation to optimize the parameters of PID controller. It also gives the minimum error at the end of the every iteration for our reference. Friends, it may be noted that genetic algorithm is very slow processing algorithm. Therefore, it takes a lot of time to complete its optimization. Sometimes it may take even hours to complete. Therefore, you have to show patience and wait for a long time to completely see the final results. Furthermore, depending upon the processor and MATLAB version, it may take even more time to complete the optimization. Friends, you can see on the screen that optimization has terminated. The minimum error obtained using the genetic algorithm is shown on the MATLAB screen. Friends, in your case, this error may be different due to the different processor and MATLAB version. Furthermore, every time you start the optimization, it may give different results due to the random initialization of the variables. Furthermore, the optimized parameters of the PID controllers are shown in the form of variable kk as shown here in the workspace section. Double click on this variable kk to see its values. You can see it provides 9 separate values for proportional gain, integral gain and derivative gain of each PID controller respectively. Now double click on this scope to see the optimized frequency response by genetic algorithm. You can see the genetic algorithm has successfully optimized the PID controller and has provided the best response compared to conventional AGC model without genetic algorithm. The genetic algorithm has best response in terms of extremely minimum undershoot and extremely lesser settling time as compared to without genetic algorithm. Friends, in this video I have discussed how genetic algorithm can be used to optimize the PID controller's parameters of automatic generation control of two-area power system in the MATLAB Simulink software. If you have watched my video on conventional AGC model of two-area power system, then you might be aware that I have simulated many cases in AGC model for different power mismatches. I will suggest you to apply all those cases here in this model to get the optimized genetic algorithms response for every different case. Or read any latest paper on this topic to get some idea about different cases. Whatever you choose, this model can be used to complete your master degree or PhD research objectives. Furthermore, you can even write research paper from this model and you can publish it in any journal. By repeating the same strategy, the genetic algorithm can be implemented for any model related to any field in order to complete master or PhD research objectives. For your convenience, I have uploaded this model and MATLAB fitness function program in the form of link in the description section of this video. You may download it from there. That's all for today's tutorial. If you like it, then don't forget to like my video, subscribe my channel, and share this with all your friends so that they may also get benefit from this video. Thank you very much.